Hello, everybody, and welcome to our webinar on renewable hydrogen. My name is Brian Stewart, and my partner Joe Wachunas and I from Electrify Now will be hosting today. We have three fantastic experts on hydrogen who will be introducing in a moment, and they will be doing most of the presenting after we get through this little introduction here. I want to start out by just giving people a little bit of background on who we are really quickly. Electrify Now, we're a voluntary organization. Our mission is really to help people understand their role in helping us transition to a clean energy future and the benefits that imparts to all of us along the way. And we try to keep it simple, help people understand why this is so important, and then help them to take three really important steps in their own lives, which has to do with getting clean electricity into their homes, basically eliminating anything in our homes that burns fossil fuels, electrify your home, and then look to electrification of transportation with the awesome options that are out there and getting better every day. And then finally, step number 4 is about all of us can help to make sure that people don't get left behind in this important transition, particularly low-income communities, frontline communities that are struggling perhaps to pay their own energy bills and might have a tough time transitioning. We don't want them to be left behind, so that we call Electrify Everyone. There's tons of information on our website about this, tips for how to do this in your home, why you'll be happy you did. We have trusted resources lined up to help you to do this and discounts for many of those suppliers. So check out the information on electrifynow.net. I also want to give a quick shout out to our coalition, the Electrify Coalition, who helps us to produce this webinar series. It's about 30 groups all interested in helping people transition to renewable energy or working on energy policy, or in some cases, these are installers of really fantastic equipment. Anyway, this group is really essential to helping us put on this webinar series. And if any of you out there might want to join our coalition, please let Joe or I know. Joe, do you want to talk about our, oh, you're on mute there, Joe.
Yeah, absolutely. Our past episodes, go to just Google Electrify Now, YouTube, or go to our website, electrifynow.net, to check out all our educational resources on electrification, everything from our webinar on induction cooking to heat pump water heaters. We're trying to cover the basis of all these electrification topics. So check them out. And we, of course, we announced it in our last webinar, but we want to highlight our Carbon Sequestration Week and our follow-up email to this webinar. I'll send you all the links, and you can also find them on our website. We're doing 5 events during the week of March 8th, all devoted to sequestration, starting with carbon capture and storage, going to forests, grassland, green concrete and soils. We're so excited to be really doing a deep dive on sequestration because it's going to be such an important part of solving our climate crisis. And then as those of you who have come to our webinars before know, or as you signed up, we asked for donations for the Electrify Everyone Fund. As Brian said, we're just a volunteer organization, and we collect donations for this fund that buys new heat pump water heaters and installs them in income qualified households for free, and replaces old aging natural gas water heaters. It saves a lot of carbon and it saves these families a lot of money. To date, we've replaced something like 15 water heaters, and we've raised over $100,000. We've raised almost $2,000 just from our webinars alone. So thank you to all those who have given so far, and all of your donations go towards this fund. We're talking about hydrogen today, and we just wanted to say just a minute, why hydrogen? You know, as you've seen, if you've seen us before, we're usually talking on subjects ranging from water heaters to solar, to wind, to induction stoves. So why is hydrogen a little bit off topic? Well, those of you who are thinking about an electrified future know that there are some things that are difficult to electrify. And there's questions about storage. Where can we store this energy when the wind isn't blowing and the sun isn't shining? So that's why we wanted to invite these expert guests on hydrogen and to talk to us today about this exciting new possibility for energy storage. So let me introduce our panelists today. Our first panelist will be Martina Steinkusch. She's the interim executive director of Renewable Hydrogen Alliance. She's been with RHA since 2019, and she has a background in urban energy, smart grids, and small-scale hydropower. RHA is a member of our Electrify Coalition, and Martina is just a great resource for all things hydrogen related. Then we'll be hearing from Evan Ramsey. He's the Senior Director of Renewables at Bonneville Environmental Foundation. Evan's been with BEF for 6 years, and he leads their work on renewable energy and demand response, as well as their work on hydrogen. And then finally, we'll be hearing from Michael S. Graham. He's the Director of Policy and Communications for the Columbia Willamette Clean Cities Coalition. Michael's goal is to support fleet decarbonization. And today he'll be talking a little bit about hydrogen being used for transportation. So with that, we'll stop sharing our screen and we'll turn it over to Martina, our first panelist. One last word, please put your questions either in the Q&A or the chat box for our panelists, and we'll answer them as many as we can. Thanks.
Great. Can everybody see and hear me?
Yes. Perfect.
So thank you very much for joining this webinar today on renewable hydrogen. Let me start off this webinar with a fact from the National Renewable Energy Laboratory. In 2019, the US annual hydrogen production was not only once, but twice the energy produced by all the wind installed in the US. So now you might be wondering, wow, this hydrogen economy in the United States is thriving. What's the hook? Well, sadly to say, most of the hydrogen today produced in the United States is produced from fossil fuels. We have an opportunity to change this. So about 2.5 years ago, the Renewable Hydrogen Alliance was created. We are an Oregon-based nonprofit with now counting more than 70 members. And not only from the obvious project developers, law firms, and manufacturers, we also represent not only gas utilities, but also electric utilities, a Native American tribe, but also clean energy and clean transportation advocacy groups. Together, we want to promote using renewable electricity to produce climate neutral fuels, to reduce our dependence on fossil fuels. We're currently covering many Western states in the United States and Canada, but mostly we're active here in Oregon and Washington State. So what is renewable hydrogen and what is its relation to climate neutral fuels or clean fuels? Well, actually renewable hydrogen is a climate neutral or clean fuel, which is created from renewable electricity. What renewable hydrogen is not, it's not a primary energy source, such as solar or wind. It is an energy carrier similar to electricity, just in the form of gas. So how do we produce renewable hydrogen? This happens in a process called electrolysis and in a device called electrolyzer. Well, this might be a very complicated and difficult sounding name, but in fact, it's a very simple process which only requires 2 ingredients, which is electricity and water. So this is a technology that is more than 200 years old and has been deployed already in Europe around 100 years ago on utility scale. So think about it as a bucket of water and you're shooting an electric current through the water. In this, here a chemical process is happening where oxygen is created and that hydrogen can be captured, and it has the opportunity to decarbonize many of the hard to electrify sectors that Evan, our next presenter, will be talking more about in detail. RHA believes that we will need all the renewable electricity that we can have, along with energy efficiency. But there will be some really hard to electrify sectors where renewable hydrogen or clean fuels can cover that gap to get us to 100% clean energy grids. So what's all that hype about renewable hydrogen right now? I mean, as I earlier mentioned, it's already existed 100 years ago, and countries such as Norway were the first ones to put those electrolyzers on the grid. And similar to a lot of renewable energy economies, we are building out our renewable electricity here as well, here in the States, in Oregon and Washington. But what happens is that there are times where we just produce too much renewable electricity and we cannot use it. There's not enough demand for it. So if there is no enough demand for it, there is an option to potentially sell it to another state, but they might be also facing the same problem and don't want excess renewable electricity. So another option would be to store it. So what are the options that we currently have? Batteries. Well, batteries are only that big, but we could and we should use those instead of wasting all this excess renewable electricity, and could do something better with it. For example, to create clean fuels. And now another factor that is coming into play is that because many of other countries, like in Europe, Australia, and many countries in Asia are deploying renewable energy technologies, the cost for the devices, for these electrolyzers, they are dropping. And this combination of the many renewable energy surpluses that we're currently facing and the falling costs makes renewable hydrogen a very cost competitive scenario. So how does renewable hydrogen fit into a clean environment? Obviously, this could tackle the problem of our emissions. Many of the questions that we hear is, well, would you need to build out more renewables, renewable energy sources to facilitate renewable hydrogen? Like, no, we are already experiencing the surpluses, so we will not require an additional build out of renewable energy sources. So we just should simply tap into the surpluses that we already have. And as we're building more and more renewables here in our region, we'll have even more of those surpluses that we can use to produce clean fuels locally. Many of the sectors that we could, or clean hydrogen or renewable hydrogen could decarbonize or electrify is, for example, transportation. Here we talk about fuel cell electric vehicles, but we're not only talking here about passenger cars. Let's think a little bit bigger. Let's talk about trucks. Let's talk about planes. Let's talk about ships, rail. Some of these applications would be really difficult to electrify through batteries. But most importantly, let's also not forget about hydrogen as an industrial feedstock. In the first slide, I've shown that currently hydrogen is used to produce fertilizer. Similar to the cement or the steel industry, hydrogen is currently required as an input to create these materials. And there is an opportunity to electrify industrial feedstock as well through hydrogen. But most importantly, let's not forget, we always talk about economy and the environment. There is a whole other aspect and spectrum of, our communities. many of our communities, that are impacted by emissions are, on corridors along highways or close to ports, close to power plants currently emitting, toxins into the air. And, our sector would be able to help and to help these communities if we would be able to move into a clean energy future. So how does it relate as a storage battery for electric generation? So renewable hydrogen can replace natural gas. We've been seeing this happening all around the world. For example, just recently in British Columbia, the province has mandated that by 2030, so not very far away, 15% of the gas energy delivered in the province must come from renewable gas, which might be renewable hydrogen or renewable natural gas. We are seeing applications which we call power to gas applications, for example, in California a lot. One of them, for example, at UC Irvine, they're injecting local hydrogen into the campus pipelines for heating. One of our members, Mitsubishi Power, they have really a big project in Utah. There is a big coal power plant that's powering LA, and currently what is happening, they are transforming this old power plant, and it will be running on 100% renewable hydrogen, and will be powering the LA area with clean fuels. As I earlier mentioned, this is something that is happening all around the world. And just to show you, the US here is not marked as one of the leading countries. For example, Australia, many European countries, Canada, China, and even Chile, the governments have committed with $billion to develop the renewable hydrogen industry, because they see that this can be a key to decarbonize their economy. The US, unfortunately, has not taken that step, but we are seeing electrolyzer developments in some regions. If you look at that big green balloon in Washington, this will be probably having the largest electrolyzer project of the United States that is currently being built. Evan will talk a little bit more about that. So we hope that with the new Biden administration and also having reviewed Biden's climate plan, it includes a pathway for green hydrogen. We are very excited about this. A recent report by McKinsey has estimated that the market might be worth $750 billion per year and would create 3.4 million new jobs in the US. It's something really worthwhile to look towards too. So yeah, if you have any questions, feel free to reach out. Thank you.
Perfect. Thanks so much, Martina. And Martina will be answering questions in the chat, and then during our Q&A portion at the end. I want to launch a quick poll as we, sorry, I'm just launching it right now. A quick poll to see where everyone is coming from as Evan loads his slides. Evan, go ahead and do that. And just curious to see where everyone, we know that we have a Northwest base, but curious to see where.
And just one other thing, I see we have a lot of good questions in the chat, and we'll try to, with our experts, to help answer some of those as we go, but have a little patience, please. We'll hope to get to all those, as many of them as we can. Thanks. Okay, so I ended the poll. I'm going to share the results with everyone. Obviously, we're Oregon-based, but lots of folks coming in from Europe and outside the United States. So welcome to everyone on the webinar.
Okay, I'll turn it over to Evan. Go ahead.
Great, thanks, Joe. Brian, pleasure to be here today with the panel and with all of you out there. My name is Evan Ramsey. I'm the Senior Director of the Renewables Program at the Bonneville Environmental Foundation. We are a 501c3 nonprofit. We've been around for about 20 years, and we work in the areas of energy, carbon, and water. My program works to break down barriers to renewable energy adoption, and our focus areas lately have been community solar, low-income solar, low-impact hydro, EVs, renewable hydrogen, and electrification. And myself, I spend a majority of my time on renewable hydrogen these days. Originally, I came out of the solar sector, and have really grown to appreciate the opportunity that exists with renewable hydrogen. And I'll share some of those thoughts with you today. So I'm going to start off talking a little bit about why hydrogen, build upon what Martina introduced, and then move into which sectors renewable hydrogen could be applied to as end uses, and then talk a little bit about some developments we've been seeing in the Pacific Northwest. BEF has been active in several developments with partners here, and then talk a little bit about the global momentum we're seeing with hydrogen. So first off, Martina mentioned the reason we're talking about renewable hydrogen today is really all because of renewables and the cost declines that we've seen in wind and solar, and the fact that the more and more wind and solar we build, the cheaper that becomes, and the cheaper electricity is in the wholesale markets. And unfortunately, it has a negative effect where the value of that next incremental wind or solar kilowatt hour decreases to the point where the prices start really, approaching a floor. And that's where renewable hydrogen can come in, and it starts to make sense to turn that very low cost, surplus, clean electricity into a fuel. And we're starting to see that across markets in California, in the Northwest, and all of these other locations across the world. This is going to be a phenomenon that's pretty ubiquitous. And so this graph is a little bit busy, but it illustrates, the role as this hub that hydrogen can play, and this role of pulling clean electricity off the grid and directing it into these other sectors that Martina alluded to. Some of them have pathways to direct electrification, and some of them are a little more difficult to do that. But hydrogen has the potential to store that renewable electricity in a gaseous form or liquid even, and then apply it to these other sectors. So we've got, the chemicals industry, we've got petroleum refining, we've got transportation, fertilizer production, steel refining, even, natural gas infrastructure, repurposing that to use hydrogen. And so I've circled here the few areas of focus that we at BEF have looked at, including, how do we produce renewable hydrogen, and then how does it apply to the natural gas system, to transportation, and to ammonia, which is NH3 formula there. We've conducted some market analysis and some cost modeling, and identified one of the earliest, best business cases for renewable hydrogen is for transportation. If you're competing with existing fossil-derived hydrogen or the natural gas system, you're competing with the cheapest energy source we have on Earth currently, and that makes for a tough business case for hydrogen. But in the transportation sector, you're competing with relatively higher cost refined products like diesel and gasoline, and hydrogen can see better revenues and better returns in that application. The other thing that the transportation market has going for it is it's got early public visibility and acceptance. People don't necessarily see hydrogen as a solution today, and seeing more of these clean vehicles on the road can help bring people along to appreciate the opportunity. And also, the transportation sector is a big bugaboo in our decarbonization efforts. It's, you know, the majority of our emissions. There's a need to reduce those emissions, and there's a big addressable market that a lot of renewable hydrogen could be sold into. This is a graphic I like to share with folks that was produced by Matthew Klippenstein, who I believe is now one of the co-chairs of RHA's communication committee. And he's a journalist and a fuel cell expert in British Columbia. But these lobster claws illustrate, you know, the breakdown in the future of pure battery electric vehicles and hydrogen fuel cell electric vehicles, because they are also an electric drivetrain with onboard storage as hydrogen gas. In the light duty sector, battery electric vehicles make a lot of sense, but there will be a role for fuel cell vehicles with any application that is high utilization or heavy duty even. And so on the right side, we've got our heavy duty transport breakdown with a majority likely trending in a fuel cell drivetrain direction, and a smaller subset being pure battery electric. Part of the reason for that is weight. You see this graph here, you know, the farther you want to go with a battery electric vehicle, the heavier your vehicle gets because you need more batteries on board. And that's not the case with hydrogen fuel. It's extremely light, the hydrogen element, and you can add more and more fuel onto a vehicle without dramatically increasing that vehicle's weight. So you can get more range, and you don't have to take up payload on your vehicle with the batteries. The other dynamic at play is just how businesses operate. And, you know, time is money, and there is downtime to charging a vehicle. And a business that wants to have maximum uptime for productivity or revenue purposes wants to be able to refuel quickly. And so while there may be disadvantages for, you know, cost of hydrogen fuel or the inefficiency of the process, economics can sometimes trump those elements and trend a business application towards fuel cell and hydrogen. Forklifts are one great example. You know, a lot of the goods that are moved around the country today by, you know, Amazon and Walmart and other big companies are already using fuel cell forklifts in their warehouses. This is a report came out recently, and it has projected that fuel cell electric vehicles will be less expensive than pure battery electrics and internal combustion vehicles on a total cost of ownership basis within the next decade. So EVs have had a great success story over the past 10 years. And now that we have renewable hydrogen as a realistic opportunity that can be affordable now with low cost renewables, fuel cell transportation, you know, has some catching up to do, and it's about 10 years behind where battery electrics are today. But there are indications that the opportunity is there, and California, for example, is now going to make zero emission heavy duty vehicles a requirement. And so, you know, going back to the previous slide, some of those may make sense for battery electric vehicles, battery electric trucks, but the business case and the operational characteristics for fuel cell transportation will fill a large portion of that fleet in California, at least. And this graph here from UC Irvine, you know, shows a projection of the demand for renewable hydrogen going out to 2050. And, you know, today in 2021, you know, barely even registering on this graph here, but orders of magnitude growth over the coming decades. Switching gears here a little bit, you know, I wanted to talk about ammonia, which is another energy carrier and a more efficient, denser way to carry large amounts of renewable hydrogen. Once you've gone through the process of electrolysis, that's the lion's share of the energy needed to make the hydrogen gas. And with a little bit more energy, you can pull the nitrogen out of the air through the Haber-Bosch process and fix that nitrogen to these hydrogen atoms and create a much denser energy carrier that is renewably produced. Ammonia currently feeds the world. It's what goes into most of our fertilizer production that's applied to crops all over the world. And so there's a big need to green up that process alone through renewable ammonia, as most of that ammonia is coming from natural gas today. So we move millions of tons of ammonia around the world currently today. And while the substance can be toxic, it can be safely handled like many, many other fuels. And its prospect as a globally traded renewable hydrogen commodity, ammonia looks to be a good solution for that, that industry. This is a quick blurb here just showing that, our current process of creating ammonia from fossil natural gas has pretty substantial methane emissions, and cleaning that up is also going to be an important opportunity for renewable hydrogen. Ammonia as energy storage here, we can compare this Hornsdale battery storage project in Australia, which is the biggest in the world at the time, 129 megawatt hours stored there. Whereas we've got, liquid hydrogen storage facilities at Cape Canaveral that, NASA uses to fuel rockets at 9,000 megawatt hours, one single storage tank. And then liquid ammonia is typical, tank size here, 312,000 megawatt hours is almost 2,500 times bigger than that battery electric storage facility. So, the scale and the magnitude of, that hydrogen and renewable ammonia can operate on is, really just staggering and already, commercialized today. The International Maritime Organization is also looking at how they can regulate emissions for marine transportation. And this is also how a lot of goods get moved around the world. They've identified ammonia as the primary fuel choice for going to zero carbon transportation across the oceans. Again, batteries don't make a ton of sense because you have, multi-day and week voyages, and batteries are super heavy. Whereas ammonia could fill this role quite well and stimulate a lot of economic activity. They're projecting $50 billion a year of investment to decarbonize the maritime industry alone. So moving into kind of what we're seeing both locally here in the Pacific Northwest and around the world, as Martina mentioned, the world is embracing this opportunity and has some pretty bold and ambitious targets. And we are lagging behind a little bit here in the United States. But one of the projects that us and at BEF are involved with, we've partnered with Toyota and Douglas County PUD, and we're in the process of delivering the first renewable hydrogen fueling station in the Pacific Northwest, thanks to a grant from the Centralia Coal Transition Grants. We are in the midst of site selection and equipment selection to site a light-duty fuel cell electric vehicle fueling station, and Toyota has agreed to bring up 10 of their Toyota Mirai fuel cell vehicles that will be sharing and demonstrating with fleets across the state of Washington. The hydrogen fuel for this station and these vehicles is coming from Douglas County PUD's brand new electrolyzer that they'll be locating at their hydro facility in East Wenatchee in central Washington. So all of the fuel will be coming locally from within Washington and from a renewable electricity source. The other project that we are involved with is a collaboration between the Eugene Water and Electric Board and Northwest Natural Gas. And they're working together to also deploy an electrolyzer and look to inject that gas into the natural gas pipeline there. And of course, in this instance, it would also be supplied by eWeb's renewable electricity. But one thing the team found very quickly is that you can only blend a certain percentage of hydrogen into the pipe without concerns around materials or pipeline embrittlement. And that wouldn't allow for a very large project given kind of the pipeline composition and flows in that area. So they're looking to methanate the hydrogen and capture a CO2 source that would otherwise be emitted into the air and recycle that CO2, combine it with hydrogen and put a synthetic methane into the pipeline where they won't be volume limited anymore. So a real interesting application, and the opportunity to put renewable hydrogen in our existing pipelines is a very cost efficient end use for hydrogen. The pipes in the ground are essentially an existing storage vessel where we could place this surplus renewable energy. And so it's relatively expensive to move hydrogen around in gaseous or liquid form, and our pipeline system is already fairly ubiquitous. Eventually, we could move towards pure 100% hydrogen pipelines, which is a relatively cost-effective way to move large amounts of energy around. And lastly, one of the efforts here we've got in partnership with the Renewable Hydrogen Alliance and the Center for Sustainable Infrastructure is a regional renewable hydrogen action plan, where we've convened dozens of experts in the energy industry, government, maritime, many other sectors I'm forgetting to mention, but this spring we'll all be coming together and providing some recommendations that the region can take to advance renewable hydrogen across multiple sectors. I'll try to blow through these last few slides so we have plenty of time for our other folks. But we're seeing indications that momentum is building, and certainly there's a lot of hype around renewable hydrogen, but the scale that it can operate on is really staggering. We see stats here. Hydrogen could take 25% of all oil demand by 2050, a 10 trillion addressable market by 2050. The EU has put in place plans to promote $470 billion of investment into renewable hydrogen. So, a really big deal, and other countries are taking it very seriously. Even here in the Northwest, across the border, British Columbia has some, pretty staggering metrics here on the opportunity. In particular, they're hoping to get 1 million fuel cell electric vehicles on the road. And they see a massive opportunity in export revenues, using their good renewable resources in that province and exporting that renewable energy to more resource deficient countries like Korea and Japan. This here was a recent announcement. GM is partnering with Navistar and 1H2 and JB Hunt. Not a great picture, but what they're looking to do is develop heavy-duty fuel cell trucks, which, as we learned earlier, work a lot well for zero-emission transportation in the heavy-duty sectors. And then in the light duty sector, there are major auto manufacturers that have big goals for light duty fuel cell electric vehicles. Hyundai here, Toyota, as I mentioned earlier, and Honda all have light duty fuel cell sedans that are running on the roads in California today with 40 or 50 fueling stations in operation. And then I'll wrap it up here. There's been some very big project announcements. I think Martina's slide showed this maybe better than here, but there's some links here to more information on any of these projects and some additional resources if folks want to do their own reading. So I will wrap it up there, and thanks for the time, and I'll try to get to some questions here in the rest of the session.
Perfect. Thanks so much, Evan. And Michael, we'll go right to you so we can have some good Q&A afterwards. Thanks, Tom.
Awesome. Can you all see my slides all right? Awesome. Well, good afternoon, everyone. Terrific presentations from Martina and Evan. Thanks for the intro, Joe. Thank you, everyone, for attending today. Electrify Now for coordinating this event with our presentations, as well as the opportunity to share information on hydrogen transportation with you. My name is Michael Graham. I'm the Director of Policy and Communications here at Columbia-Willamette Clean Cities Coalition and the current coordinator for the Western Washington Clean Cities Coalition. Together, we represent fleets and clean transportation stakeholders from across both Oregon and Washington. The Columbia-Willamette Clean Cities Coalition is a 501c3 nonprofit and part of the greater U.S. Department of Energy Clean Cities program, which is a public-private partnership between the U.S. Department of Energy, national labs, and fleets on the ground using clean fuels and technology, as well as industry stakeholders, policymakers, academia, those sorts of folks that are operating within our region. Our mission is to really provide education, information, outreach to help reduce traditional petroleum consumption within the transportation sector. We would provide what you would call fuels agnostic support to our stakeholders, technical assistance, trainings and education, grants and incentives and deployments, such as helping the Salem-Keizer School District here in Oregon deploy the first electric school bus in the state of Oregon, as well as recently being funded by the Portland General Electric Company for Oregon's first all-electric refuse truck operating in a minority-owned Portland business, and then just generally functioning as a large network connecting like-minded fleets from across the Northwest and even the country. Here's just a snapshot of some of our members. Many of them are local here to Oregon and the Washington area. So a quick fun fact for you for the day, hydrogen gas is the world's smallest molecule. It easily powers some of the largest equipment, including mining vehicles or locomotives. There's only a few key differences between internal combustion engine vehicles, I'll call those ICE vehicles, and fuel cell electric vehicles known as FCEVs. FCEVs operate much like a locomotive. They produce electricity on board using another fuel source, hydrogen gas, and then power their wheels and drive their wheels with electricity. FCEVs are almost identical to battery electric vehicles. The key differences are they've got a smaller battery pack and an onboard generation system in the shape of a fuel cell. They fuel up pretty quickly. It's about as long as it takes to fuel your gas car today and have a very long range. They operate well in all weather conditions. And additionally, they have like the pep and power of electric vehicles thanks to electric motors. In terms of emissions, hydrogen fuel cell vehicles produce zero tailpipe emissions. Their only byproduct is actually water vapor. And comparing the carbon intensities of hydrogen fuel cell vehicles and the hydrogen that drives them, we can achieve emissions lower than that of gasoline and diesel when looking at the total life cycle of a fuel's feedstocks. And life cycle means the process of taking their feedstocks out of wherever they are, whatever their feedstocks are, processing and production of those feedstocks, distribution of a finished fuel, and its final use in a vehicle. That's what's known as a wells to wheels analysis. And even when the carbon intensity is higher than that of gasoline and diesel, hydrogen vehicles still produce fewer total carbon emissions compared to internal combustion engine vehicles, thanks to the greatly improved efficiency of FCEVs versus ICE vehicles. I like to compare, for instance, Toyota's Camry and their Mirai. Their Camry gets, let's say, 26, 36 miles per gallon on gasoline, but the Mirai is going to get 65 miles per gallon equivalent on, the same amount of energy content in their fuel. A gallon of gasoline has 114,000 BTUs, and a kilogram of hydrogen also has 114,000 BTUs, yet you're getting around 30 miles per gallon on a gallon of gasoline or 65 miles per kilogram of hydrogen. So why is everyone interested in hydrogen? It's this really hot fuel. Some joke, it's the fuel of the future for the past 25 years, the next 25 years. It's safe to say that we've kind of crossed a threshold here. I mean, hydrogen is really gaining a lot of attention, and actually we're seeing, serious developments in the technology. But what's sparking the interest? Of course, there's zero tailpipe emissions. The only byproduct is water vapor. but there's also a lower total cost of ownership, or we see a line of sight to a lower total cost of ownership as the technology matures. And it's trending down, and it's competitive with compressed natural gas, traditional fuels like gas and diesel, and also battery electric vehicles. There's resilience, which was alluded to by Martina. You can produce fuel and electricity in place for extended periods of time when, under the correct operating conditions and the correct installation. It works well in fleets and augments other fuels such as battery electric and natural gas. And then performance, again, quick refuel time, all weather operation, power and efficiency. I want to show you just a quick example. So that's pretty impressive. In Oregon, the main interstate here is I-5, and that goes north to south. And there's a lot of trips between California, Oregon, and Washington. And between Oregon and California, for example, there's 6 mountain passes that you have to climb. And if you're a heavy duty trucker and you're using a diesel truck, you're in the far right lane, limping along at 20 miles per hour, shifting constantly up and down, between your lowest gears. Going super slow 6 times. But if you're in a fuel cell electric heavy duty truck, you're just zooming past all of those guys in the mid lane with all the light duty vehicles like myself, in my sedan. So hydrogen works in quite a few situations, like heavy duty trucks, but where does it thrive? If you're looking at some of the most demanding applications, we're talking about doing work, hard work, and it's in fleets where you need large amounts of continuous power, you need long ranges between refueling, and you need to refuel quickly to reduce downtime. As Evan mentioned, warehouses and distribution are really interested in hydrogen. So in terms of sectors that really like this kind of fuel as a potential, mass transit, fleet vehicles, freight, and especially material handling. For example, Walmart is moving to fuel cell forklifts because of their higher uptime and productivity, meaning Walmart can move more products faster and be more competitive than its rivals, all with 0 emissions. I wanted to just touch base a little bit on what's going on in Oregon. Not a whole lot. We've got one demonstration vehicle. It's a hydrogen fuel cell Mirai with an awesome license plate that you'll see in my last slide. And there's a lot of interest, but there are some key barriers. There's a need for collaborative planning to identify infrastructure sites. There's also a need to, fund those fueling infrastructure sites. And then just general incentives to help consumers and fleet operators purchase fuel cell electric vehicles and equipment. Meanwhile, in California, it's like a whole new world. Testing is underway for a myriad of heavy-duty fuel cell pilot truck platforms with the likes of Toyota, Daimler, Nikola, Hyundai, and powertrain manufacturer Cummins, all moving towards hydrogen fuel cell technology or demonstrating something today. Then there's transit, which is yet again spearheading adoption of clean fuels technology, just as they did with CNG in the 80s and battery electric in the mid-2000s. That sector in particular is farther along than the rest of the hydrogen fuel cell industry, arguably, simply because they're increasingly finding hydrogen as a lower cost option to reduce emissions to 0, as prescribed by regulation in California. And they've deployed dozens of units to do so. The state's home to 48 fuel cell electric transit buses. For perspective, there's about 60 right now in the US. And then there are agencies in California are ordering another 28 buses. They're interested. As I mentioned, transit sees that business case to support low emission attributes of hydrogen fuel cell. Foothill Transit in Southern California, for instance, found that they would need fewer fuel cell electric buses, known as FCEBs, than battery electric buses to achieve 0 emission operation. For example, along a 42-mile route, they estimated they need 34 battery electric buses or 23 fuel cell electric buses. That's a 1.5 to 1 replacement ratio for all electric versus a 1 to 1 replacement ratio for fuel cell. Infrastructure costs were also found to be more to be lower for that route. And Foothill estimated they need $4 million for a hydrogen fueling station to support those 30 buses, compared to about $11 million required for infrastructure to service 34 battery electric buses. Per mile costs of fuel cell electric buses are pretty low. They're about $1. Battery electric's about 76 cents. The midlife replacement costs for fuel cell buses are just 3/20ths of that of a battery electric bus. So you're looking at $200,000 for a midlife replacement of a battery electric bus versus only $30,000 for a fuel cell bus. That's a lot of money for a transit agency. Overall, Foothill estimated fuel cell electric buses would save the agency nearly $13 million compared to battery electric buses over 12 years of useful bus life. And that's not to say that fuel cell is the end all be all. I mean, we're looking at, kind of an all fuel solution here, but rather fuel cells are just another feasible option for them to leverage during their electrification efforts. Electric buses have their role to play, and so do hydrogen and fuel cell. In conclusion, hydrogen vehicles are excellent in heavy duty, hard work applications, all weather conditions, quick refueling times, and helping augment and not compete with all fuel types, including battery electric vehicles. Looking at Oregon specifically, there are some significant barriers facing fuel cell electric vehicle deployment, and it's going to take leadership from policymakers to spur the market. Fuel cell electric vehicles are new and developing, and if given some time and support, they'll mature. It's estimated that fuel cell electric vehicles are about 7 years behind that of battery electric vehicles. So there's a little bit of room to catch up. And then we also need light duty and heavy duty fuel cell electric vehicles in the market to advance. And I'll give you an example. Light duty is going to spur the mass production, right? Reduce component costs and the high fuel demand of heavy duty electric vehicles from fuel cell electric vehicles will help reduce the cost per kilogram for the hydrogen fuel. Looking at the carbon intensity of hydrogen hydrogen transportation fuel used in California, for instance, it's clear that hydrogen vehicles can produce zero tailpipe emissions and also even fewer life cycle carbon emissions than gasoline and diesel vehicles. And then finally, I want to leave you all with the same note that I left the Oregon State Legislature and their Joint Transportation Committee just 2 weeks ago. It reminds you that this is a global race, at least for us in the US. Fuel cell electric vehicles, battery electric, all of it is a global competition. And these technologies offer us not just a lower emission future, but a lower cost one. And if our fleets are going to be competitive on the global stage, they're going to need cost competitive fuel cell and electric technologies. And let me tell you, we're behind. So in Europe, fuel cell transit buses cost only about $900,000. And in the US, we're still around the $1.2 million mark. But we know that the cost of the buses will come down as production scales up. So we see a line of sight to lower costs and a business case, and it is important to expedite this arrival to ensure the competitiveness of our fleets going forward. Not to mention, we have a climate crisis, and we have to reduce emissions now. So hydrogen fuel cell provides a very viable option to reduce emissions now, and I'd strongly suggest we consider it as just another tool in our toolbox to do so. So with that, I really appreciate your time and the invitation to present. Thank you, and I'm happy to answer questions.
Fantastic. Thanks so much, Michael.
It's been a pleasure.
Thanks, Martina. Great. So we will send all these slides to everyone who's registered afterwards. Let's get to a couple question and answers. I know our panelists have been answering feverishly in the chat and the Q&A. So one good question here, I'm just looking at our Q&A list. Where do we expect the investments for hydrogen infrastructure to come from? With the need also to build out infrastructure for battery electric vehicles, is there enough money to fund both of these new infrastructures? And anyone can answer that who would like to.
I'll take a stab. For fueling infrastructure, I'd say there is. In California, for example, the low carbon fuel standard is a policy that has created a free market that has allowed lower carbon fuels to be valued higher than higher carbon fuels, and has really funneled a lot of revenue towards the low carbon fuel producers from the oil industry. And that revenue has allowed private industry to pick their own perception of what is their winner and their loser. And they're picking quite a few hydrogen fueling sites as where they want to invest. That's not to say that there's not electrification investments too. The utilities have invested there, the state has as well. But what's interesting is that private investment is really focusing a lot now on hydrogen fueling infrastructure. So you're seeing a mobilization of quite a few pots of money And I don't think that it's going to be, we only have one set pot, to draw from. You're going to have plenty of funding to go into both of those fuel types.
Thanks. I have a question for you. I know it came up a lot in the chat and Q&A, and it might have been answered in some cases, but I bet you a lot of people have heard this before, that the hydrogen process of, creating the hydrogen from renewable energy, there's some inefficiencies there. And then there's inefficiencies again when you take that hydrogen and convert it basically back to electricity for transportation, or whatever the application is. Can you guys speak to that? Because I think some people see this black and white picture that battery storage is more efficient than hydrogen, so therefore batteries are better. But it seems like it's not really that simple of a case. Can you guys speak to that a little bit?
Yeah, and I don't think that the conversation should be what is better. I think we need both. It depends which application you're looking at. Do airplanes running on, flying with batteries, do they make sense? Or cruise ships? I think the bigger picture, or the bigger idea that we want to answer here is we need to decarbonize, and we should not get stuck so much on efficiencies, and efficiency might be an issue on a small scale, but we need to decarbonize as soon as possible, and all the tools that we can, use to help us to get to our goals. I think, maybe Michael could talk a little bit about, fuel cell efficiency.
I'm no engineer. I just come from a world where it's like there's a fuel for every application. It's an all fuel solution, and I'd say that based upon the application, you're going to find the fuel that fits best to achieve your goals. For instance, you showed the slide about LADWP. I mean, maybe they looked at stuffing that salt cavern with a bunch of batteries, but lithium ion batteries. But they at the end said, what, storing it with hydrogen is going to be a way better option.
I would also add to this efficiency discussion that we don't want to conflate efficiency with economic drivers, and economics is often what is what business and industry is going to follow, or it's going to be what dictates the decisions they make. And so if we have an abundance of curtailed renewable energy on our system, it's essentially free. And so if you can access large amounts of that otherwise wasted energy with electrolysis, the efficiency doesn't so much matter anymore, because it's either use it or lose it. And so that's, and you get a cheap renewable hydrogen product by doing that. So batteries can't fill that role. You have to build so many batteries, it becomes very, very cost prohibitive. But hydrogen can fill that role, and it can capture that value through a relatively inefficient process, but it's going to get wasted otherwise.
Martine, I heard you use the word airplanes just a minute ago there, and I'm fascinated by this. There wasn't much discussion of it in your presentations today, but are there developments going on around air travel with hydrogen?
Yes, definitely. We had, probably in the last 1 or 2 years in the US, we hear that some airlines are experimenting with clean fuels, not necessarily with renewable hydrogen, but with other clean fuels. I think Alaska Airlines has been one of them. But I also know that, a lot of stakeholders within the aviation industry is currently looking how to make use of this, renewable hydrogen, and to create clean fuels. And I know for a fact that there are organizations and companies here in Oregon and Washington that are currently looking into this, working with our local airports to, hopefully we'll see something in the next 5 years, and to replace the jet fuel, that's currently created from fossil fuels and imported from far away, not even created locally, you know, so there's opportunity.
Question here, we're at the hour, but maybe we'll take another question or two. So someone says that this has been mostly a pro-hydrogen presentation, and those of us who are pro-electrification sometimes don't talk about some of the issues with electrification. I wonder if you could tell us about some of the sticking points in hydrogen. What are some of the hurdles that need to be overcome, and where are some of those sticking points?
Well, I'll jump in here. I mean, first and foremost, this is a relatively new phenomenon that renewable hydrogen is even an opportunity, because the decline in wind and solar costs have happened so quickly and rapidly. So we're just now as a society coming to grips with, well, we can take this low cost resource and capitalize on it and decarbonize these other sectors. So, public awareness and education is really the biggest, barrier. And hopefully, we're taking some baby steps forward here. But the other is policies, and we've talked about low carbon fuel standards. Cap and trade has been funneling a lot of money in California into clean vehicle infrastructure. So we need policies that are going to generate revenues that will encourage investment in hydrogen infrastructure, also battery electric infrastructure, so we can grow the demand for renewable hydrogen. That's what's lacking today, is there's no demand pull for this potentially large amount of fuel that could be created.
Thank you. I have one question I saw earlier in the chat that I kind of intrigued me. I think a lot of times, we wonder about unintended consequences of this, that, or the other whenever we're looking at these new technologies. I noticed there was one attendee who asked about potential impact on the water supply if we're using water with electrolysis to create the hydrogen. Are there any concerns about that?
Yeah, there are some questions about it. And to produce 1 kilo of hydrogen, you would need 9 kilos of water. Now that water that will hit the electrolyzer should be ideally clean, or has to be clean. But we know that our members, we represent also electrolyzer manufacturers, they're experimenting also with dirty water, where you could have kind of like a cleaning device that's attached to the electrolyzer. So you could potentially use not super clean water that can be converted in a process before it hits the electrolyzer to use this. So yeah.
One other point, Martina, and I think it's on the fact sheet on RHA's website that we worked on, but in terms of in the transportation application, we use a lot of water to refine our petroleum fuels already, and on a per mile basis, it's actually less water use to electrolyze water than it is to refine gasoline. So if we're just supplanting the existing fossil fuels in our transportation fleet, it could be a net water reduction in terms of use. Now, you probably don't want to put a bunch of electrolysis out in the desert where you're pulling fresh water from other needs. So, you have to be thoughtful and careful about where your water's coming from, and that it's not exacerbating other issues.
A similar question along that line is around heavy metals, and I think with batteries, I think there's a lot of conversation about the metals that are needed in batteries, and that is a cause for concern. Is there anything similar to that with the electrolysis process?
Well, there is a little bit platinum that's being used, but to my knowledge, the platinum that is being sourced from non-controversial regions in South Africa and Canada. Again, there's been a lot of research and development looking into replacing platinum, and I have read in the last years that such breakthroughs happened, but yeah, again, it's not such an issue as the batteries have with the cobalt.
Great. Well, I think we are at 1:05, and so I know there's still a lot of questions that we didn't get to, but we did get to a lot answered. We will send out this recording and all the slides afterwards, along with the email addresses of our panelists. If we want to continue the conversation on email, we can do that as well. Thank you to everyone for joining us. We're so thankful to our panelists, Evan, Martina, and Michael, for being here with us today. We'll remind you that Sequestration Week is March 8th, so we hope to see you then. Till then, good luck with your electrification projects, and thanks again to our panelists.
Thank you very much.
Thanks, everyone.
Thank you all.